Welcome to Expanding Brackets Level 3, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're expanding and simplifying this expression. Now, since we have two separate brackets, we need to expand each of those independently and then simplify afterwards. So to start, we can multiply 4 by 3y, and this gives us 12y. Next, we can multiply 4 by minus 2, and this gives us minus 8. Next, moving on to the second bracket, we have 2 multiplied by 5y, which is positive 10y, and finally 2 multiplied by 7, which is positive 14. Now that we've expanded these, we can collect together the like terms. So starting with the y's, we have 12y plus 10y, which gives us 22y. And then moving on to the numbers, we have minus 8 plus 14, which is the same as 14 minus 8, and this gives us positive 6. So our final answer to problem 1 is 22y plus 6. In problem 2, we're expanding 6m multiplied by 4m squared n minus m n squared. Now here we can use our laws of indices, and we know that when we multiply indices together, we add the powers. So anything that doesn't have a power on, I'm just going to add a power of 1 onto. And now when we multiply, we know we just need to add the powers together. So starting with 6m multiplied by 4m squared n, we can start with the numbers. 6 times 4 gives us 24. M to the power of 1 multiplied by m squared becomes m cubed because we add the powers, and then we also have an n on the end. We now need to multiply 6m by mn squared. Now in front of this m we actually have a minus 1. So we can start with the numbers again, and we have 6 times minus 1 is minus 6. Then m to the power of 1 times m to the power of 1 is m to the power of 2 because we add the powers, and we also have an n squared on the end. These are not like terms, so we can't simplify any further, and so 24m cubed n minus 6m squared n squared is our final answer. In problem 3, we're expanding and simplifying this expression. And again, since we have two separate brackets, we're going to expand them separately and then collect like terms afterwards. So here we have 3a multiplied by 4a. Now 3 times 4 is 12, and a times a is a squared, so we have 12a squared. 3a multiplied by 5 gives us plus 15a. We need to be really careful here because this 6 has a minus in front of it, so we're multiplying the second bracket by minus 6. And if we start with minus 6 multiplied by a squared, this gives us minus 6a squared, and next we multiply minus 6 by minus 1, and the two minuses multiply together to make a plus, and 6 times 1 is 6. Finally, now that we've expanded these brackets, we can collect together the like terms. So we have a 12a squared minus a 6a squared, and this gives us 6a squared. And the remaining two terms are not like terms, so we just have a plus 15a and a plus 6. So 6a squared plus 15a plus 6 is our final answer to problem 3. In problem 4, we're expanding 7p squared q multiplied by 3pq minus 5p cubed q squared. Now here we can use our laws of indices again. So anytime we multiply indices together, we can add the powers. So I'm going to add a power of 1 on this q, a power of 1 on this p, and a power of 1 on this q. And we can now start multiplying. So to begin, we're going to do 7p squared q multiplied by 3pq. So starting with the numbers, we have 7 times 3 is 21. Moving on to the p's, p squared times p to the power of 1 becomes p to the power of 3 because we add the powers, and the q's, q to the power of 1 times q to the power of 1 becomes q to the power of 2, or q squared, because again we add the powers. Next, we can multiply 7p squared q by minus 5p cubed q squared. So starting with the numbers, 7 times minus 5 is minus 35. Moving on to the p's, we have p squared times p cubed, which is p to the power of 5, because again we add those powers together. And finally, q to the power of 1 times q squared gives us q to the power of 3, because 1 plus 2 is 3. Since these are not like terms, we can't simplify any further, and our final answer is 21p cubed q squared minus 35p to the power of 5 q cubed.